All right, in this video, I'm going to go over the answers to the derivatives from a table practice problems. Again, it is best practice for you to try the problems on your own and just check in here for the solutions. Let's get started. The first question is just h equals f minus g, and then they want us to find h prime of 1. So the first thing you're going to do is to symbolically manipulate the derivative here, just saying h prime equals f prime minus g prime. These are just power rules right here. And then to find h prime of 1, we sub in 1. So we get h prime of 1 is f prime of 1 minus g prime of 1. Going to the table, f prime of 1 is negative 2, and g prime of 1 is 2. So negative 2 minus 2 is negative 4. Next, we have a product rule problem. So to differentiate j, we apply the product rule. F differentiates to f prime, leaving g intact, plus f times the derivative of g. Then you're going to sub in 2 for each x. Then you find from the table that f prime of 2 is negative 1, g of 2 is 2, f of 2 is 3, and g prime of 2 is negative 2, and all in all, I get negative 8 for the answer. Next problem is a quotient rule problem. So I need low d high minus high d low, square the bottom, and away we go. And then evaluate the table. From the table, f prime of negative 2 is negative 1, g of negative 2 is negative 3, f of negative 2 is 1, g prime of negative 2 is 4, and g of negative 2 is negative 3, and that all simplifies to negative 1/9. Now we have a chain rule problem in number 4. So we take the derivative of our outside function f, leaving g intact, and then multiply by the derivative of our inside function. Then let's sub in values from the table. G of 0 is equivalent to negative 2. So that means we have f prime of negative 2 times g prime of 0, which was 1. And then from the table, f prime of negative 2 is negative 1. So this gives us a negative 1. Q equals f of x plus 3. This is a simple power rule problem. So first they want us to just get q of 1. That's the substitution. Q of 1 equals f of 1 plus 3. From the table, f of 1 is 2, so q of 1 equals 5. Then we have a power rule for q prime of 1. It's just equal to f prime of 1 because 3 differentiates to 0. Then from the table, f prime of 1 is negative 2. Number 6, we have a chain rule problem. So we need to take the derivative of f, so f prime of x cubed. Oops, excuse me. First, we're doing just p of negative 1. So we just need f of negative 1 cubed, which is f of negative 1, which is 0. Then for the derivative, we have a chain rule problem. So p prime of negative 1 equals f prime of x cubed, which is negative 1 cubed, times the derivative of x cubed, which is 3x squared, where the x value is negative 1. So f prime of negative 1 from the table is negative 2. So that gives us negative 2 times 3 times 1. So our answer is negative 6. All right, for number 7, we also have a chain rule problem. E to the f of x. E differentiates to itself, so e to the f of x times f prime of x. In this case, our x value is 2. So we have e to the f of 2 times f prime of 2. So that means e to the 3 because f of 2 equals 3, and f prime of 2 is negative 1. So this is a negative e cubed. Now we want to find the equation of the tangent line of the function g at x equals 1. So we know from the table that g of 1 equals negative 1. That is right here. G of 1 equals negative 1. Then we also need the derivative of g at 1. So I come to 1, and then g prime of 1 is 2. And I use that to write an equation of a tangent line. I have y plus 1 equals 2 times x minus 1. That's in point slope form. And now our last problem is a chain rule problem. If I want w prime, I take sine going to cosine, leaving my inside function f of x intact, times the derivative of f of x, which is f prime, minus, well, cosine going to negative sine, which is why I have a subtraction, sine of f of x, leaving the inside function intact, times the derivative of f, which is f prime. Now let's plug in negative 1. Cosine of f of negative 1 times f prime of negative 1 minus sine of f of negative 1 times f prime of negative 1. From the table, f of negative 1 is 0, and f prime of negative 1 is negative 2. Cosine of 0 is 1. 1 times negative 2 is negative 2. Sine of 0 is 0. So 0 times negative 2 is 0, so this expression zeroes out, and we're left with just negative 2.